Oh, sweet. Let's see if it's working. All right, so real quick on this, you definitely have to know. Yeah. See the top half of this? All right, those. Except for the tangent. Everything at the top half of this, except for the tangent double angle and tangent half angle. I won't make you memorize those. And one reason I don't make you memorize those is, I will be completely honest, I never memorize those. I just make them when I need them. Past that, let's see. Oh, and the sum and difference identity. So the top half minus the tangent double angle, tangent half angle. Right? So far so good? Or understood, anyway? And obviously the law of sines. Now there's even one on here I didn't even realize. There's a law of tangents, which we're not going to talk about at all, but there it is, just in case you were curious how many of the laws there were. There's at least one more there. And the sum and difference identities. Maybe it would have been quicker if I would have said what you don't need. You don't need the product to sum. You don't need the sum to product. You don't need Mollweis's formula, whatever the hell that is. Don't even know how to pronounce that. And you don't need law of tangents. You don't need to use ecalc.com. Okay. Is that clear? Has everybody got that?
So what did you say about some differences of identity? We should or shouldn't?
Yes, these are the ones you should know. The top half minus tangent 2 theta minus the tangent double angle, tangent half angle. You don't have to know those. You have to know the top half of the paper plus the law of sines.
So we do need to know law of sines.
Yeah. So this is what you got to know.
Okay.
Make a list of everything you got to know. Top half minus tangents, law of sines, sum and difference. Minus tangent.
Bless you.
Okay. Cool. So does everybody understand? Anything else? If I ask you a question that requires the use of something else, I'll put it on the test. I'll put the formula on the test. Yeah.
Just to clarify, in the law of sines, the way I remember it was like sine of capital A over A.
Yeah, they like to use Greek letters, which you see a lot.
Just making sure it's the same thing.
You'll see that in the book every now and again too. So it's either capital letters or it's the Greek equivalent of A, B, C, alpha, beta, gamma. Okay. Is there any other questions about any of that stuff? Okay, cool. So what we're going to do today is we are going to finish up chapter 6, or 7, sorry. And then we're going to get just a little bit into chapter 8. Okay. So I'm just going to throw something at you. See what you do. Make sure everybody kind of starts off I could have actually put any number there where I got 6 underlined, because how many answers are there to this? Infinite number, because of the periodicity of trig functions. So find the main 2, and then try to build off of those. So, I don't know if any of you guys are worried that I didn't say a word about which quadrant we're in. If that even came into your mind. Which quadrants must I be in for the answer to this? 2 and 3. Why 2 and 3? Because cosine's negative in 2 and 3, right? So where the x is negative. So I know I've got to be in 2 and 3. What's the reference angle going to be? 45. So some of these are going to be, in fact, a lot of them are going to be, in order for us to be able to do these by hand, they have to relate to outcomes that we know. So we know root 3 over 2, we know 1/2, we know root 2 over 2, we know 1 over root 3 and root 3 for tangent and cotangent, right? And all the reciprocals for secant and all that kind of crap. So you're going to see those kind of numbers showing up a lot. If it's some other number, then you just use inverse to do it, right? So, and you can use inverse cosine here too. How would I know? But you just told me that the reference angle has to be 45. Either up or down from 180.
So you want us to use degrees for this?
Yeah, you can use degrees. I was going to put degrees and radians.
Okay.
Get used to, what I want to do is I want to, some of you guys seem to not be very comfortable working with like reference angles purely in radians. I saw in a lot of people's tests, the first thing you did was convert it to degrees. You've got to get very comfortable working directly with radians. So let's go ahead and work with radians right from the beginning. So what would that be in terms of radians?
3 pi over 4.
Well, the reference angle would just be 5 over 4 up or down. So this angle here, yeah, 3 pi over 4. And this angle here, yeah, 5 pi over 4. Love it. So pi over 4 before pi, pi over 4 after pi. Cool. So those are like your 2 primary answers. Any other answer is going to be a little tiny bit lame in the sense that they're going to be the same freaking angles, just with rotations to get there, right? So 2 answers are 3 pi over 4 and 5 pi over 4. What's one more answer somebody has for me? Negative, or oh, say it again. 7 pi over 4. Now, where would 7 pi over 4 be?
3 pi over.
You got to be careful. It would be over here, wouldn't it? So, do you all agree I must be in the second and the third quadrant? If you give me an answer that's over here, your cosine's going to be positive. Couldn't possibly answer that equation.
11 pi.
So the right way to do this is you could take this answer and add
2 pi.
add 2 pi. That'll give you one more answer. You can subtract 2 pi. And over here you can do the same thing. 5 pi over 4 plus 2 pi. 5 pi over 4 minus 2 pi. You don't have to come up with negative answers. You can give me 3 positive. I didn't say. You could have added 2 pi, then added another 2 pi. So really, visually, all I'm doing is, here's one answer. So another answer's got to be 2 pi away from that. Or it's got to be negative 2. You know, that's all we're doing. So it is, in one sense, a little bit lame in the sense that they're all the same angle. You guys kind of with me? But we have to realize that sine functions and cosine functions don't always, and here's a sine, so this, even though it keeps repeating values, it's still important to know what it is over here, even though it's the same thing it was over there. So I still want to get an infinite number of answers. Just because it keeps repeating doesn't make it any less relevant that this is this value and so is this one. Who cares? I still need to know what it is way the hell out here. Okay, maybe. That's why I'm careful about using the word lame. I don't want to use that too often. Because many students already use it too often. All right. So then what do you get here, for example? 11 pi over 4. And here, you have negative 5 pi over 4. And here you get 13 pi over 4. And here you get minus 3 pi. So there's 6 answers. 1, 2, 3, 4, 5, 6. Cool. Okay. So you're going to see a variety of things in the homework. Let's say this is part A. Part B, find all solutions. And this is kind of like what I did at the end of class last time. If one solution is 3 pi over 4, how do I get all the other solutions?
Plus 2 pi n.
Yeah, some multiple of 2 pi. Right. I think the book, I can't remember what they do. I always hated n. I can't remember if they used n or k. They use k, good. And you're all like, what do you got against the letter n, Jeff? Well, because n normally represents natural numbers. But what did we just do here? We used an integer multiple of 2 pi. We used -1 multiple of 2 pi. So k is kind of like our catch-all, some integer value. So I can go forward rotation or backwards rotations. How we doing? So on one level, I'm hoping to God that this is kind of, easy. Some of these are going to be exactly like this. If I said sine theta equals 1/2, you can figure out what angles make that happen. And then add some multiple of 2 pi. This would be an answer for find all solutions. Or if they say find 8 solutions, make k 1, 2, -1, -2. Then you get several solutions, several specific solutions. Hopeful. Here, try another one. Try to make this one a little more interesting. So find little bit of algebra get you there. And then what angle are we talking about then? What angles?
7 by.
Yeah, because which quadrants do we definitely have to be in?
Three, four.
Yeah, the third and the fourth. That's where y is negative. And for sine to be small, it's got to be closer to the x-axis. So what's my reference angle going to be? Good. 5 or 6. So then one angle here it's got to be past pi. So it's got to be 7 pi over 6. And then the other angle to there, 11 pi over 6. Pi over 6 shy of 2 pi. Yes, ma'am.
How do we go from negative 1/2 to pi over 6?
Two things. For one thing, I knew it was in these quadrants just because it's negative. Okay, cool. And then I talked about the reference angle because that's what we should have memorized. Sine of what is 1/2? Good. So that's what we got to think about. And remember, the way I remember this is if sine's small, it's got to be close to the x-axis. So that's 30 degrees is the closer to the x-axis one. So I got a reference angle of 30. And now I just have to work out, okay, it's pi over 6 past pi or pi over 6 before 2 pi. And I can get those specific radian measures, right? How are we doing so far? So long as you know your trig values, should be all right. So we got 7 pi over 6 and 11 pi over 6. So that's part A. Part B says find all solutions.
Those averages plus 2 pi.
Yeah, 7 pi over 6 plus 2 pi k. 11 pi over 6 plus 2 pi k. Cool.
How come when you write out find solutions in that, they're both done in brackets?
What's up? Sorry?
Like where it's 0 to 2 pi for the interval matrix?
Oh, because 2 pi is 0, so it would be, what I really want here is, like for example, if the equation was sine theta equals 0, what's the answer there? Or what's the answers? Where's sine equal to 0? 0 and pi. 2 pi would be adding 2 pi onto this, so that would be a repeat already. So I want that initial one to be just the basic angles, and then everything else would be rotating from there. So that's why it's a good question. He's asking, why don't I put a bracket there? Because 2 pi is 0. It would be part of the repeated answers, the other answers. Cool. All right, there's part B. So this isn't terribly hard. The thing to remember, though, is so far I've done sine and cosine, and their periods are 2 pi. So let's try a tangent one out. See what's different. So the same two things. 0 to 2 pi. And then all solutions. Yes, sir?
Is this 7.3 or what is it?
This is 7.4. Yeah.
Where did 7.3 go?
7.3 you talked about. We did.
What's the hardest?
So a lot of 7.3 is just going to be looking back at the functions. Some of them you've got to memorize, but a lot in 7.3 you don't. So it's really, for that case, it's just going to be plug in and chug it. So in the homework, I just want you to get used to those formulas exist. How can you use them? I'm not going to make you memorize them, which actually makes the homework kind of easier. You just look at the function, you plug the stuff in the right place, and you chug it out. So 7.3 was nothing really new. They might have some more verify the identity questions, but we kind of know hopefully how to attack that now. We just have more identities that we could use. So where must I be? What quadrants must I be in? Yeah, 2 and 4. I've got to be where the sine and cosine are different signs, so that tangent being a ratio of the two comes out negative. So I've got to be in 2 and 4. And of course, since tangent is a ratio of sine and cosine, I have to be at the angle where they are the same, and they're the same at what angle? The reference angle, pi over 4. So I know I'm here and here. I know the reference angle is pi over 4. So what's this angle, this first angle here? 3 pi over 4, I love it. And then this angle, yeah, pi over 4 away from 2 pi. How are we doing so far? Okay. Hidden in the background of this, if you have any trouble, is all I'm doing is when I draw the picture, I'm telling myself to do this to figure out what that angle is. Because it's pi over 4 behind pi. So subtract. This is pi over 4 behind 2 pi. So again, subtract to get that 7 pi over 4. So if you have to, you can certainly do that. You have to be able to draw that picture though. And hopefully we should be able to do that. Notice something really cool about tangent. Its period is pi. This is not always going to happen, but it happens very often. Its period is pi, and how far apart are these two answers? Pi. Sine and cosine so far, every single one we've done, how many expressions have I needed to express all the answers? 2 expressions, right? Because there was no way to go from this to this and then all the way back to here. There's no one multiple I can do. You guys kind of with me? Because these are a different length apart than these are. But tangent's awesome. All I have to do, so the answers in 0 to 2 pi would be 3 pi over 4, 7 pi. That's in 0 to 2 pi. Now how do I get all the solutions? I do not need 2 expressions here. Because if I do 3 pi over 4 plus pi k, cool. You guys with me? Maybe. Yeah. And the reason that is sine kind of repeats values at different, like it's here and here and here. So it kind of repeats it at different intervals. Whereas tangent, it's going to always be pi apart when it repeats. Always. You can see that from the graphs. So very often, tangent you can just write in one single thing, and very often you've got to write sine and cosine's answers in 2 separate ones. Possibly even more, which we'll get to later. Maybe we'll get to it right now. How are we feeling so far about this?
Good place at that point.
I know. I always got to mess it up right at the end. It's easy until right now. Here we go. All right. So what if I were to put down here? I'm sorry. So, nothing has changed about how to solve equations. Basically, it can't. You can just learn more and more functions to throw into an equation. So, with trig functions, I could go one more step past here. I could take the inverse tangent of both sides and then get theta by itself. But before I get there, I always want to get the thing that has my variable in it by itself first. And I've got inside sine theta, that's where my theta is. But then I've got to get rid of this stupid square then. That's my first thing, is to uncover that. So of course, what do I do to both sides? And the minute you do that, plus or minus so you don't lose anybody. So then you get sine theta equals plus or minus 1 over root 2, which is root 2 over 2. So you guys kind of see what I mean. And this will end up having a nice thing happen. So which quadrant could I be in then? Any of them.
Yeah.
Sine theta could be positive or negative, so that's solved. Right? What's the reference angle going to be? Yeah, the pi over 4, so it's all the way around. Pi over 4 reference angle. Da, da, da. So this first angle, I'll do it pi over 4. Yay, Jeff. What's the next angle? Yeah, this will be 3 pi over 4. And then 5 pi over 4. And then finally, not surprisingly, 7 pi over 4. Yeah. Oh, square root of 1/2 would be 1 over root 2. Yeah, yeah, and then just rationalize it.
So you're just adding and subtracting from pi to
Now in this case, the period of sine is still 2 pi, but you look at how far apart these guys are. So who's got one option for how to write? So this is like part A. Part B would be all solutions.
Pi over 2k.
All right, good. I got a kind of a clever way to do it. Every single one of these, how far away is this one?
Pi over 4.
Pi over 2. And how far away is this one?
Pi over 2.
Pi over 2, and how far is that one? Pi over 2, all pi over 2 apart, right? You guys see that?
Yes.
So one way to do this is, in fact, this is the way to do it, really. The first way I was going to do it would be a kind of a mistake. You could do pi over 4 plus k pi. You guys see that? And then you have to do 3 pi over 4 plus k pi. So you'd start here, and then you get this one, and then you get that one, and then you get this one, and you get that one. Sort of like we did with the tangent. But then you have to do the same thing with this guy, so you can get all these guys here. Let me say this again. These are the main 4 answers. Every single other angle that is basically stops at these same locations is also an answer. So one way to do it is to start with pi over 4 and add pi to it, and then add pi again, and then add pi again, or subtract, so any multiple of pi. So you have to do pi over 4 plus k pi, and you have to do 3 pi over 4 plus k pi. But a much smarter way to do it is to take pi over 4 plus, k pi over 2. And then that's in one expression catches all of the answers. And why could I write it in one expression for all the answers? Because they're all the same exact distance apart. This guy, I couldn't do it because they're not the same distance apart. Close, far, close, far. So I can't do a single multiple of something. I'd have to do 2 different expressions. Okay, how we doing? If you did write that, I would not count you wrong. I would just pull a note. You can write it in an easier way because this is not wrong. This still gets all the answers. It's just an easier way to write it. Right? Easier is not necessarily wrong. Okay. So let me ask you this then. Let's do this here. What, Jeff? I don't know. Cosine theta equals. I'll just say find all solutions. So just in case you didn't memorize all the angles down to this detail, you will need your calculator. So they're going to give you a couple that are like this, where this is nothing that I know. Right? I don't know what the hell. So I have to do the inverse cosine. And when you do that, for one thing, I'm asking you to be in radians. You have to get used to radians. You don't want to be afraid of these radians. They're going to be everywhere for the rest of your mathematical lives. I guess I should do it too. Yep, 1.148. Okay. So it's positive, so which quadrants must I be in? First one? Or the fourth one, yeah. One of those two. Okay, one, so I'm definitely in those. My angle is 1.148, which is not something, it's sort of like saying, you know, it was about 7 decimeters away from, we don't know freaking most of us. Where's Annie's not here, so she knows metric. 1.148, I don't know what the hell. But what is pi over 2? 1.57, right? And half of that would be just to like 0.7 something or other. So this is a little more than halfway. It's a little more than pi over 4. So it's going to be about right there. And of course, you could always convert this to degrees. Did anybody do that? What is that in degrees? Just out of
It's
curiosity.
like 65.
65 degrees? Roughly? Okay. All right, cool. So you got to be there or here. That reference angle would be 1.148 rad. So somebody help me out. One answer is 1.148 plus what? Yeah, 2k pi, or 2 pi k, however you want to do it. So one set of answers is taken care of. How do I start this guy off? How do I figure out what that actual angle is? What is this angle here?
Negative 2 pi
minus.
Good, 2 pi minus 1.148. So come and approximate that for me. 2a, so 5.13.
5135.
5.35 roughly. Second?
Can we use negative dot number?
No,
Why?
because we want these primary ones to be in between 0 and 2 pi normally. Technically, you wouldn't be wrong, but we do want to kind of, it's convention to relate everything to an angle between 0 and 2 pi. Because that's where we normally feel the most comfortable. Everything else is just repeats of those. So technically, you wouldn't be wrong. Conventionally, you would be. Normally, when you do something like that on a test, you don't lose a lot of points at all. But it's still convention. And of course, here again, plus 2 pi k. Cool. Yeah.
So 2 pi minus the 1.14, that equals 5.
Yes, good. Yeah, because 2 pi is 6.28, blah, blah, blah. All right. How are you feeling there? So on one level, that's an easier problem because I just do inverse cosine, let the calc do the work. On the other hand, it makes this just a little bit uglier because we're not used to looking at 1.148 radians. What the hell's that? Okay.
Where you get the 5.12?
This is a reference angle of this. So what's the actual angle? It's that far behind 2 pi, right? It's that far behind 2 pi. So if it was this, if the reference angle here was pi over 3, what's the actual angle going to be? 2 pi minus pi over 3. Yeah, same thing. We're just not used to seeing it in decimal form. Because I don't know, pi divided by what is it? I don't know. Shit, I'm just gonna leave it in decimal form. I don't know what pi divided by what. I don't know. Alright, maybe. Okay. Oh yeah, so let me throw this in. Here we go. Here's where it gets really fun. I'm so evil. Alright. Now one little trick to this is if you rewrite cosine as c, tangent as t, sine as s, it kind of makes the equations a little more evident. So if I write cosine as c, that's 2c squared minus 7c plus 3 equals 0. How do I solve that? Don't say quadratic. Quadratic. You only use quadratic if you cannot factor it, and you can factor this. So you know this has got to be 2c and c. You know this has got to be 3 and 1. You don't want to put the 3 there because then that'd be 3c and 2c. That's never going to make 7c. You need 6c and 1c. And in order for that to make negative 7, they both have to be negative. Okay, so don't make more of that than it is, which is not much. So yes, it's not that we find a way to bring factoring back in. It's more you learn, the minute you learn factoring, you're now able to do most math problems, because most math problems somewhere have an idea of factoring in them in the real world, or something related to factoring. So now I can bring back, what's one of the answers here? 1/2, so cosine theta equals 1/2, and I can solve that the way we've been doing. What do I get over there? 3. And what do you know about this? What's the highest number that can come out of cosine? 1. So what answers do I get from this? Fuck this. Exactly, nothing. Because there is no theta defined to make cosine 3. Theta can only make it from negative 1 to 1. So there's no answers here. And again, nothing new. You've seen this way back in Math 90. You saw this, where you had one thing lead to nothing, undefined or no real numbers or whatever. And of course, what do you get here? What angle gives your cosine at 1/2? Yeah, what quadrants do I have to be in? 1, 2. Careful now. Yeah, 1 and 4. Cosine is x. And now just to check in again with my SOHCAHTOA people. Do you understand now how knowing cosine is x and sine is like y, that helps you out in a much broader range of things than SOHCAHTOA ever can? Good. Doesn't mean you have to let go of your SOHCAHTOA, but you have to embrace the sine likes y, the cosine likes x idea, and it helps you out with this kind of thing so much. X is positive at 1 and 4. So what are my two base angles? My primary angles? Yeah. Pi over 3 and 5 pi over 3. And then you just plug on there 2k pi, 2 pi k, however you want to put it. You pick up all the other possibilities. Cool. So you can always find this, and then based on what they ask for, if they ask for all solutions, you throw these on. Be careful if it's tangent or sine or cosine or whatever the situation is. You throw in some kind of multiple of pi or 2 pi, or even pi over 2 like we saw earlier. Or they say find 6 specific solutions. You just start adding 2 pi, subtract 2 pi until you get as many solutions as they want. Because you have an infinite number of solutions here to pick from. Oh, well, why not?
3, that was 2 pi minus.
Yeah, because the reference angles are pi over 3. So to find this angle, you do 2 pi minus pi over 3. Yeah, so 6 pi over 3 minus pi over 3, 5 pi over 3. Does anybody actually go get pi after you're done with this class? For some reason today now I'm talking pi, and I'm like, I actually would like some pi. Let's do one more from this section. Where's an interesting one? There's an interesting one. Semi-interesting. I mean, really think back to when we were talking about exponentials and logarithms. Then they had equations with them in it. So you had ones you had to factor, you had ones you had to square root, you had ones that you had to do whatever. So anytime we learned a new function, you were going to look at equations that have them living in it, and then how to solve those. And they're pretty much always just going to be examples of what do you have to do here?
Factor out.
Factor. Yeah. So what comes out? Cosine theta?
This is still 7.4, right?
Still 7 for you. So you get cosine theta is 0, or sine theta is 2. So the sine theta is 2 is crap. Doesn't tell me anything because it can't happen. And if you think back, we had some like e to the x equals 0 possibilities, and that was crap. That doesn't lead to any answers. It's really the same thing. And cosine theta equals 0, the base answers.
Pi over 2. Pi over 2.
And 3 pi over 2. But the nice thing to realize there, here's pi over 2, 3 pi over 2. So I can start here and just keep adding multiples of pi, and that'll catch it all. So I think hopefully you guys notice how critical it is to draw this for yourself so you see what the hell's going on. If you don't draw this, I don't understand you. You're going to make mistakes, I can guarantee it. If you don't draw yourself what the hell's going on, trust me. Or it's going to be harder than it needs to be.
It doesn't matter if we do like plus pi k, or k pi, it doesn't matter.
Doesn't matter. That's fine.
What's it? How come sometimes you write it?
I don't know.
Like that?
Just depends on how I'm feeling that instant.
So there's not like a conventional way to do it?
Not really. I've seen it both ways. I've never heard anybody make a big deal of it, but normally the k, it actually depends. I mean, normally you think of it as like a coefficient of pi, but multiples you could think of it, like multiples of 2 could be 2x or 2n. N2 looks weird, so it kind of depends on the situation. Here they're both symbols, so it doesn't really matter. It's a convention, don't worry. Either way you want to put it. Okay. Oh, cool. So, let's do this. Here's the plan for the immediate future. I want to do some from section 7.5. We'll take a break, and then we'll get into chapter 8. How's that sound? Golden? All right.
This was also for
This is all 7 for you.
The quiz is next week?
What's that?
The quiz is next week, or?
Quiz
Next Wednesday.
14th. All right.
Next Wednesday.
Yeah. No, what did I just say? I
Let's
just
go to
said it.
Mexico.
Huh?
Let's go to Mexico.
Sounds great. You go first.
Not gonna be here, but it was.
Oh yeah, let's try this here. Here's where things get, well, I'm not gonna say that.
Let's do it fine.
There's mass confusion going on right now.
I love it. The life of the teacher. Gotta say things at least 3 times. So sine 3 theta equals negative 1/2. So the main, obviously the big difference here is my sine has a 3 theta in it, that's just a theta. Do not worry about that till the end of the problem. So really this is sine of some angle equals negative 1/2. So the first step really doesn't change. What's 3 theta going to be?
3 of those angles.
So work it out real quick. What quadrants do you have to be in? What are your primary angles? The first steps are the same as the ones we just did. I want to see if they have one here. Oh, good. Okay.
That's negative 30 degrees.
Sing it.
Right, negative 30 degrees.
Not negative. I don't want to. The primary angles have to live in 0 to 2 pi. Yeah. So what quadrants am I going to be in?
3 and 4.
3 and 4. That's where the sine's going to be negative. Negative 1/2 is going to be where the angle is closer to the x to make the sine small. So my reference angle is going to be 5 or 6. So 3 theta could either equal good 7 pi over 6, or 11 pi over 6. And again, you can always, if you want to, this is going to be 2 pi minus pi over 6. And this would be pi plus pi over 6, just because it's pi over 6 past pi. So it's a very visual idea that gets us to the math. So if you're a visual person, embrace this. And of course, on both of those, I can say, what here? Yeah, in fact, I have to say plus 2 pi k. So I can pick up all the possible answers. Now, the very last thing you worry about then is the fact that I don't have theta. I'm not done yet. I've solved for 3 theta. You with me?
Mm-hmm.
And we did exactly what we would have done if this would have just been x. Right? Then x would have been this, or x would have been this. So the last thing I got to do then is just divide by 3. So what do I get here? I get theta equals 7 pi over, please don't say 2.
18.
7 pi over 18, good. And the way to think about that is you divide by 6, and then you're also divided by 3. So you're making it 3 times smaller, so it's going to be divided by 18 at the end. Plus, I personally like to write it like that because I can see it's a multiple of 2 pi over 3 as I move around. Okay. And what happens here? Same thing, so I get 11 pi over 18 plus 2 pi over 3. Again, there's really nothing new here. Believe it or not, you've seen this kind of thing before. You've seen it when you did, I don't know, something as simple as this. So you first solve for what's in there. And if it would have just been x, you would have been done. So you solve it just like you would as if there was a single variable in there, and the very last thing you worry about is that 4. So that's exactly what we did. We solved the whole damn thing all the way as if that was just x. And then we said, oh shit, there's a 3 I got to get rid of. So the very last thing we worry about is that division by 3. Now if I'm you, I'm really curious about, well, or at least I'm worried about or concerned or wondering what the hell does that really look like. I mean, we keep talking about the visual aspect of this thing. 7 pi over 18 is not a pretty angle. You with me? And the whole reason that let's see how I can do this. The whole reason that I pick up so many more angles in a way, I get so many more angles to fit. Help me out. What are some of the main things I get out of it? Give me some answers that come out of this. So one would be 7 pi over 18. I know I always take the easiest one. What's the next one? What's like the next answer up? How would you get the next answer up? You would let k equal 1, because I just let k equal 0, didn't I? Yeah. So let k equal 1, what's the next answer up then? 7 pi over 18 plus
12 over 12.
Yeah. 12 pi over 18, which would be 19 pi over 18. What's the next answer up from there? Yeah, now you're going to have 4 pi over 3, which would be 24 pi over 18, which would be 31 pi over 18.
Can't just keep adding 12 pi over.
Yeah, exactly. Now you can start to see the pattern. Just keep adding 12 pi over 18. Right? 31 pi over 18. Where is that? I mean, which quadrant is that in? Yeah, it definitely would not be all the way back into the first quadrant, right? Because the first quadrant would be 36 pi over 18. That would be 2 pi. You with me? So somewhere below that. How are we doing so far? This is 3 pi over 2, which if you build it up to 18 would be 27 pi over 18. So I know that 31 pi over 18 is in here. Roughly in the middle, a little closer to that one. So 31 pi over 18, I don't even know what that means. Lives right in the middle of those two. Cool. So the next step would probably take me back into the first quadrant. So I actually, let's see, I really desperately hope you're with me. Mathematically, this is easy as hell. If you get the stuff we were doing a second ago, then here you're just going to divide by whatever that is at the end. Not a big deal. I'm really hoping that some of us are at least a little curious, since there's a visual aspect to this whole thing, what that really means is looks like. So from this one primary answer, this one part of it, I get 7 pi over 18, which is going to be where? This is pi over 2, so it's 9 pi over 18. So here's 7 pi over 18. And then 19 pi over 18, that's a little bit easier to see. What's that just barely past? Pi. This is right up past 18 pi over 18. So it's going to be like right there. So that's going to be 18 pi over 18. Right. 19 pi over 18. This is 18 pi over 18. Exactly. Cool. So you used to get one answer. It was just 7 pi over 6 was that one primary answer. Now I've got 3 of them in there. Of course I do. If you think about it, it should kind of give me, what does it do to the picture? Sine 3 theta. What would it actually do to the sine wave? Compress it. So I should get more answers to fit into a smaller space, because the whole thing goes up and down a lot quicker than it did before. So it's going to repeat more often. So it's a really nice thing. I'm not going to make you necessarily draw that out. I might. I think about it. But that's just one. I mean, on top of that, I have to graph these in there also. So if it would have been sine 4 theta, I obviously would have had 4 primary ones here, 4 from here, so 8 total. 4 times as many as I'm used to. Yes, sir.
If you have something less than 1.
I love it. Oh, see, I love when people are thinking the same way as me. Doesn't always happen. So if I had like cosine 1/2 theta equals √3/2. We'll do this problem, then we'll take a break. Which quadrant do I live in? Or which quadrants does the answer show up in? Yeah, it's got to be 1 and 4 where the x is positive. So 1/2 theta. What's the reference angle going to be? For cosine to be √3/2. 5 or 6, good. 30 degrees, 5 or 6. So my two primary ones before I've worried about the 1/2 are what and what? 5 or 6? I'll do that one. And careful. Yeah, right before 2 pi, which is 12 pi over 6, so it's going to be 11 pi over 6. Cool. And then to finish it out, be plus 2 pi k, like always. But of course, the same thing as before, I've got to take care of that 1/2. So I actually get theta equals pi over 3 plus 4 pi k. Theta equals 11 pi over 3 plus, what, I have 2 pluses in there? 3. 4 pi k, right? Are you guys with me? I just double both sides to kill the 1/2, of course. So at the very end, that's when you worry about the coefficient. What's true about 11 pi over 3? Where does that live? That's a weird way to say that, but it sounds more like Bob Ross at a Little Rock. Bob Ross? No. Bob Ross. Who knows Bob Ross? Nobody knows Bob Ross. Guy with the afro paints. Come on, Bob Ross. He's passed away by now, but I can make fun of him now. It's been enough time. In a little while.
The guy on PBS.
I'm not saying that I tape the show all the time, but you should have seen some kind of spoof of Bob Ross at some point on some show or something.
There's a meme out there.
Say again?
A meme.
A meme. I love it.
A meme of him painting.
I haven't seen that meme in a while, if I ever did.
White guy with an afro, right?
Exactly.
Yeah.
Paint some nature pictures.
Yes. And he speaks like that. He says, and a little tree lives here. So I was making fun of myself.
Yeah, I've seen it.
Anyway, so I'll come back. Come back away from Jeff's mostly lost reference. What the hell was I saying? Yeah, what